Yep, that's great. Thank you.
Okay, great. Hi everyone again. I would like to present the multimodal solution that our team built, which is a visual rack that can answer questions from plots. Before I begin, I would just like to say thank you to my teammates, Saeed, Suzy, Yash, and Jacqueline for their efforts throughout the entire bootcamp. Okay, so what's the problem we're trying to solve here? In many companies, including TD, work often involves finding the plots that we need to answer business questions really quickly. For example, we may be interested in finding which country had the highest gross domestic product or GDP. However, this often involves sifting through many documents as well as long documents to pinpoint exactly what we need. What we need. Typically, that's only maybe one or two plots, and that can consume a lot of time and energy. So to solve this problem, our team thought that we can leverage the power of Visual Rag to find the plots that we need. And if successful, then the solution can improve our work efficiency by around 30 to 40%, as well as lowering the mental load. Okay, so I'm going to play a quick demo to demonstrate what we have built. So it gives the audience a very intuitive idea. Can you see the video?
Yep, we can see it, but it just hasn't started playing yet.
Okay. Okay, great. So I'm going to play it. Here you can see that we have a window for the user to enter their text question, right? For example, what's the country with the highest GDP? And here by default, we try to return the three most relevant plots, right? And once we click search, you can see that the visual rack here now they provides the top three charts from its collection of charts, but also provides an insert. For example, its answer is that the country with the highest GDP will be Saudi Arabia. And if we navigate to like zoom into like one of the plots being provided, and if we zoom in, you can see from the top of the charts, indeed, the country with the highest GDP is Saudi Arabia, which demonstrates a successful use case. And here, if I go back to the slideshow, here is just a high-level flowchart of how the visual rack works. And yeah, it's simply a summary of what I have mentioned so far. Um, the the visual rack is going to taking the text query, retrieve the top K plots, generate a text insert through VOM, and then return both the plots and the text. And it took around 3 seconds for that to complete, as I've seen. And I'm going to pass the stage to Said to walk through the technical details.
All right. Thank you, Will. So if you can hear me fine, I'm gonna go over to the technical part and specifics of our methodology. So first off, we started with a raw data set of chart QA, which is publicly available. So each row comes with a chart that it could be like a bar chart, a scatter plot, etc., in different categories, as well as a question and an answer, like what is the unfavorable view in 2014, and the answer is 55. But this is not readily applicable to RAG. Therefore, we needed to first curate the questions to be globally well defined. In particular, we used like the 32 billion checkpoint of Qwen 2.5 VLM to rewrite the question given the chart and the answer into a self-contained question like this: what is the percentage of unfavorable views among Americans over something in 2014? And then for this, we built the RAG pipeline, which had like three main steps. First, we had to create an index or a knowledge base from all the unique charts in the chart QA using a multimodal retrieval like Colpally. We actually tried three different ones, Colpally, Colquen, and Llama Nemo Retriever to do a benchmarking later. The retrieval phase includes like fetching top three charts for an incoming query, which is then passed to the generator, which synthesizes an answer based on the query and the retrieved charts. We tried different checkpoints like before from Quen model, and we finally evaluated our model using 500 refined QAs from the chart QA dataset and reported various metrics like retrieval, precision recall, and LLM as judge correctness, as well as a few other ones that I'll talk about in the next slide. Yeah, here you can see like a summary of the results we received from we've seen in the benchmark. So we tried, as I said, three different retrievers and three checkpoints of Quen, which we have two listed here. As you can see, the retrieval recall is the percentage of like accurate retrieved charts based on the ground truth chart, which we know. As you can see, all the retrievers did a great job in identifying the ground truth chart in the top three retrieved charts because the queries were refined for RAG, so they didn't have a problem spotting that. And then we had our main metric for the end-to-end evaluation was the LLM judge correctness, which is basically the 32 billion version of the Quen, taking in the question, the model's answer, and the ground truth answer, which was a short phrase usually, like you said in the previous slide. And then it spits out a score between 0 and 1, which you can see the best performing combo was determined to be Quen 2 and Quen 2.1 VL 32 billion instruct. We have also reported soft match score, which is like an edit distance based score calculated over the ground truth answer and a short answer that we instruct the system prompt of our generator to produce, as well as the larger or like the big response. That you can see it's fairly correlated with the LLMS judge. We also have the generator to cite what kind of chart it based its answer on. So we can also calculate citation precision recall, which we show the recall here. You can see most of the time the generator was able to reference the right chart. Yeah, so that was about it. As you see, like the bigger checkpoint for generator did a better job, and out of our retrievers, the Colpally did the best job, but the other ones follow closely. And yeah, with that said, I'm gonna pass it over to Suzy for the rest of the presentation.
Thank you, Saeed. We definitely hit some challenges along the way. First, on the generation side, the smallest Quen 2.5 model was not a very reliable, as it sometimes failed to return a valid JSON output, which broke our evaluation pipeline. On the retrieval side, the BID is the wrapper of Colpally, but it's not yet supported the Colquen 2 and Llama Nemo, so we actually, in fact, maintain separate environment for these two retrievers. And finally, it's difficult to compare free-form RAG answers to very short numerical ground truth answers in ChartQA. So instead, we use an LLM as judge evaluation setup. So those challenges lead to some lessons for implementing such a system at TD. First, for production, we will strongly recommend models with a larger checkpoint since the cost of invalid output can be higher. And also, we learned that strict output and LLM as judge evaluations are essential. Instead of silently producing some false answers, we really want the system to detect errors in a very quick and visible way. And finally, from an engineering perspective, we recommend keeping the pipeline module separable and swappable between components, so it will be easier to swap a retriever or generator or to upgrade to a neural cocoon checkpoint. Next, please. Thank you. So for the next step, we would like to bring this closer to a real TD workflow and test the pipeline on actual charts and reports. And also on top of that, we will enhance the web UI demo that we presented earlier and to a production grade application. In the long term, we want to test if we can go beyond plots to entire PDFs, such as mixing charts, tables, and text. And last but not least, we want to include the functionality for abstention and safety. And thank you. I'll wrap up. A quick thank you for the opportunity to share our work. A special shout out to Michael and Sitar for their report throughout the bootcamp. With that, we will stop here and happy to take any questions.